And we have the great honor today to welcome two Spring developer advocates, Mark and Josh. So big round of applause for them, please. And they will talk. Yeah.
Marco?
Thanks.
All right.
And his talk is about one of my favorite features of Spring 5, which is React project. So Reactive, so go on, guys.
Merci, mon ami.
Merci.
All right, everybody, hi. Oh, terrible. Just terrible. Try again. Hi, everybody. Bonjour tout le monde. Tranquille après le déjeuner, hein? Okay, well, we have a lot to cover. We forgot the code. The code. We always forget that in the slide.
Oh, we should, yes.
So we worked very hard on this slide.
Yes.
Right? The slide has everything that, we thought this would be a great presentation, so we put a lot in our slide, but we forgot one thing of import. That's this bit here, which is...
There it is.
There we are. Can you see that? So grab that code, get the... Oh, yeah. All right. Good stuff. All right, so we have a lot of stuff there. I hope you'll take note of it, keep it for your own reference for later. That code is the stuff that we're going to walk through in this introduction today, so please don't hesitate to keep it for your own reference. A little bit about us. Everybody has that? We wait for people to take photos.
You can just change the tab too.
Can't, but they're still taking photos.
Oh.
Can we put that in the slide?
Not easily.
Oh.
We got to code, man.
Yeah.
We have to code.
All right, so we've got this slide. If you have questions, don't hesitate to ask us. We're happy to engage. We're online. We're on Twitter. How many of you have Twitter? I'm just curious. Twitter? Okay, very good. The rest of you should be on Twitter. It's 2017. Okay, so Twitter, good. What about email? How many of you are using email? Anybody here? Is anybody using email? No, very good. Okay, good. Nobody uses email. It's terrible. So moving on. But if you have questions on either one, don't hesitate to reach out to us. We're happy to talk to you. And so today we're going to talk about Reactive Spring, right? Good to see you, my friend.
We should introduce ourselves.
Well, yeah. So my name is Josh Long. I'm a Spring Developer Advocate. I'm joined by my fellow Spring Developer Advocate and friend here, Mark Heckler.
And I'm Batman. Oh, I've just always wanted to say that. Thank you. I'm Mark. So
very good. So we work at Pivotal, and at Pivotal we have a lot of great open source software. Some of you may recognize some of the open source software. We care about the open source software, but what we care about more than anything is helping organizations build better software more effectively and more quickly. We want them to be able to deliver software into production. And a lot of organizations, they move to this microservices architecture. How many of you here in the hub of Africa are building microservices? Microservices. Okay, so it's starting to get traction. That's good. It's the same all over the world. We're seeing people move to this architecture. And we're seeing people move to this architecture because they want agility. When they move to this architecture, however, they invite new complexity into their life. They invite the complexity of building a distributed system. And that complexity is very hard to address. One thing that becomes very problematic is when you start moving to a distributed systems world and you have lots of data from one service to another. Lots of data being moved across the wire, across the network. All this data makes it hard for systems to stay alive, to stay stable. So there are several things that we run into, several things that we have to address here. First of all, if you move to a distributed systems architecture where data is being conducted on the net through the network I/O, through the boundaries of the services, you have to be able to model large amounts of data. You have to be able to talk about large amounts of data. Data that may be here, that may arrive, or maybe it will not arrive. Maybe it'll take an hour, or 2 hours, or 3 hours for all of the data to come, right? Large amounts of data. That's the first thing, is we need to be able to talk about and model large amounts of data. We need to be able to model the latency as well, right? The fact that systems are not stable. Things will change. Services may fall. Services may come back online. And we also need to be able to handle, as a consumer, we need to be able to work with a large amount of data, right? We cannot say select all from whatever and get a billion records. We have to instead take as much data as we can, process it, and then move on. So these requirements require us to think differently about how we build systems. For the bottleneck in these systems is input and output. It's the movement of data from one node to another. And so in the Java world, we've traditionally built services using the Servlet API. And the Servlet API, up until Servlet 3.1, didn't really have a great way to talk about asynchronous responses, right? But when you deal with lots of data, this is important, especially if that data takes a long time to generate. I don't want to build a system where I have a response that I need to send back that may take some time. There may be latency between the records. I need to have the ability to model that latency. So this is not a new problem. Java 1.4 introduced support for asynchronous I/O in java.nio, right? But we haven't really had that support in the higher levels of the platform, in the higher levels of the application stack. We haven't seen that reflected there. We've seen different organizations try and model, this data, this potentially unlimited amount of data that may arrive eventually or asynchronously. We've seen different projects try and address this or model it, but it's taken a long time for us to find a way to just define it in a concrete way. And this model is called the Reactive Streams Initiative. How many of you have heard of that, the Reactive Streams Initiative? I'm just curious. So the Reactive Streams Initiative is a de facto standard. It was created by the people from Pivotal, by the people from Netflix, by the people from Red Hat, by the people from Twitter, yeah, a bunch of different organizations out there went out and described or put together a common set of interfaces. And these interfaces define the basic semantics of something that produces data, called a publisher, that may eventually produce data, right? It can produce 1 record or 1 billion records or 1 trillion records or no records. So that's called a publisher. A subscriber listens to the data from the publisher. It receives the data. When the subscriber subscribes to the publisher, it is given a subscription. The subscription has a very useful method. It is called request. And the request method allows the subscriber to say, I want 10 more records, or I want 1,000 more records, but only 1,000 more records. In this way, the subscriber can limit the production of data. It's impossible for a producer to overwhelm the subscriber, right? This gives you something called back pressure. It gives you the ability to push back against too much data, too much I/O. And then finally, if you have a component that is both a producer and a consumer, both a publisher and a subscriber, you call that a processor. And those are the 4 interfaces. Those are the 4 types. Now, is that enough? Are we done? Does that solve all of our problems? Of course not, right? When we build systems, we think about things at higher levels than that. We don't just use input and output streams in all of our data access in our web tier, and we don't just use arrays either. We have higher order computational models. We talk about collections, for example, and streams. So the same must be true here. We must have higher order operators to work with this potentially unlimited amount of data. And this is where projects like Pivotal's Reactor and RX Java 2.0 from Netflix and Vertex and Akka Streams from Lightbend, all these different projects provide this higher order computational model. Now, is that enough? Well, I'd still say no, right? You're still missing integration with the tiers of technology that you use to build applications. How do you build a web application with just collections? How do you talk to your database with just collections? Again, the same problem exists here. What good is this computational model if it's not integrated at every layer of your stack? So we need to support that, and this is where Spring really, really stands on its own, is we have integration at every layer of the stack with this reactive approach. And that's what we're going to talk about today. Spring Framework 5 was released 2 months ago, September, right? It was released in September of this year. Spring Framework 5 builds on the reactive streams model. And then beyond that, you'll see Spring Boot 2.0, Spring Data K, Spring Security 5, Spring Cloud Finchley, all of them build on Spring Framework 5 and this reactive support. So that's what we're going to do today, is we're going to take a look at some of these technologies, and we need some sort of demo application, some sort of sample domain so that we can build something today. And my friend Mark and I we thought about this long and hard. We wanted a simple domain that people could appreciate, they could use with ease. We thought, well, we could build an application that modeled what? Pets. Well, we thought we could build a pet store.
Yeah.
You know, that's never been done in the Java industry. Nobody's ever done a pet store, right? C'était une blague. Je plaisante. Of course, it's the most common thing. But so we thought, no, that's not going to work. We don't want to do a pet store. So we thought, what if we had something where we could work with movies?
Sure.
Right? In English, a very common way to talk about an old-fashioned word for movies is a flick. A single movie is a flick. Right? And we thought about some more. And we were big fans of this project Reactor. The Reactor project has two subtypes, two classes that extend from publisher. The first one is called a mono. A mono produces 0 or 1 value. So it's a publisher, it has the contract of a publisher, but it's specialized. And you know when you receive it that it's only going to produce 0 or 1 value. There's another type called a flux. And a flux produces 0 or infinite values, or 10 or 1,000 or a billion. It doesn't matter, right? 0 to n. So we thought flux and mono, and we thought we could do something with movies. We could build something with movies on the internet, something to manage movies on the net, using Reactor, using these types. And we thought we could build something like Netflix, right? But no. So we thought we'd do that. So we're going to build a service that manages movies, that allows us to talk about movies. We're going to do so using Project Reactor and using Spring Framework 5. And the first thing that we're going to build, of course, is a service to manage movies. So we'll go back to start.spring.io. How many of you know start.spring.io? Je vous demande. How many of you know start.spring.io? Who is using Spring? Who is using Spring Boot? Okay. So it's very important to understand. This is my second favorite place on the internet, right? My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. But if you're not already in production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before your cup of tea or coffee, start.spring.io. And if your children can't sleep, start.spring.io. And if you have indigestion after a long and terrible evening with WebSphere and PHP, start.spring.io. So we're going to build a new application today. We're not going to spend too long here. We're just going to build a new application using Spring Boot 2.0 M6. We're going to use the latest and greatest version of Spring Boot. This is not GA yet. And we're going to build something called the Flix service, right? This is the service that will let us manage movies using the Flux types from Reactor, right? Or maybe we could call this the Flux service, like so, right? There we are. And this could be shortened into FFS, or for Flux sake. So now what we're going to do is we're going to build an application using the reactive web support. We'll use the security support. Actually, I think it's actually in security now. We'll find out later. So we'll use the reactive security support. We're going to use the reactive web support. We're going to use some sort of data access layer. We need to talk to a database, right? And so we have a couple of options here. You can see them here already. You can see we've got reactive Cassandra, reactive MongoDB. There is reactive Couchbase as well, reactive Redis as well, but those are not supported in Spring Boot yet. They will be, but they're not here yet, right? So we've got a couple of options that we can use right now. They're all very good choices, but you notice that one thing that we do not have here is reactive JDBC. There is no JDBC or JPA yet. We are very excited, Mark and I, because we saw in 2016 at Java 1, they announced that they were planning to work on a reactive JDBC driver. And then last month, or 2 months ago, at Java 1 2017, they had code for this JDBC driver.
Sort of.
But who knows, at the speed they're going, it could be 2 years, easy. no problem. We could have something real, you know? So,
Or more.
well, or less.
It's kind of in a mono. You don't know when it's going to arrive, right?
Right. So it's asynchronous, but the point is, it gives me hope. Ça nous donne d'espoir. Okay, so that's good. In the meantime, we have nothing, so we won't bother. We'll use something that is natively reactive, right? Something that will produce data asynchronously and that we can consume, and then in the meantime, it will not block threads. So we have a number of different choices here, but we do not have JDBC. Now there's a lot of good choices. You could choose whichever you want, but we're going to choose Reactive MongoDB. We chose it because we have it on the machine. Is it running?
No.
Oh,
Do you want it to run?
no, I'm scared. So we're using Mark's machine today. We switch. Sometimes we use his, sometimes we use mine. When we use his, I have trouble because I use Linux, and I have to go back and remember all the keys for OS X. When we use mine, he has trouble because he has to learn all the keys for Linux. So one of us has to look bad. Today it's my time to look bad. All right.
There you go. Let's see. Yes, we are
Very
right.
good.
Okay.
Sweet nectar.
Back to you.
All right. So we have.
Yep.
So we have Reactive MongoDB because it's a fine choice. It's installed locally, and you know, say what you will about Mongo, but if you want to lose your data, and you want to lose it reactively, there is nothing better than Reactive MongoDB. So we'll leave that installed as it is. Okay. Now we're also going to choose Actuator just in case, and we're going to hit Generate, and that'll give us a new zip file. And let's see, CD downloads. Whoa.
Desktop, right? Or
Is that where you put it? Gee whiz.
Nope.
Okay.
Apparently not.
Generate project. Oh, it's still waiting.
Oh, wow.
Okay. Who's using BitTorrent?
Or on Netflix, one or the other. Those usurpers.
This reminds me of that time I was happy or sad. Let me see. Hold on. Wait. Might have an option here.
We are connected.
Oh, okay.
Look.
Desktop. Do it. Go. Hit
Desktop.
save. It's already on desktop.
Save.
I'm scared. Okay.
Oh, you went here, right?
Yeah.
Okay.
All
See,
right.
We work together. We're pairing.
Unzip that. CD. This. Open. Is that going to work?
Sure.
All right. Good stuff. All right. So we've got a new project, and this is a Spring Boot project. It's going to. Did you Maven Clean install recently?
Did I what?
Maven Clean install?
No.
Uh-oh.
It just takes a while. Yeah.
Okay. Here we go. It's coming along. All right.
Look at that. There we go.
So we have a new project, and we're going to build a very simple application here. Flux service application. Can you all see that in the back?
Maybe a little larger.
Okay, font. And we will make this a font that says,
If you just go to color scheme font, or you can do that, sure. Whatever.
force it to be larger. Good. Yeehaw. Can you all see that? Okay, good. So we're going to build an application that manages movies. So we're going to say class, did we forget something? I think we forgot Lombok, didn't we, buddy? There we are.
Did we really?
I forgot
We
Lombok.
did. Oh,
So I'm going to add in Lombok to make this a little bit less painful. So I'll use Lombok here.
because we are lazy developers.
Right,
Yes.
lazy developers.
In a good way. In a good way.
So here we go. Class movie, and the movie is going to have a few fields: private string ID and title. Right, and this is Lombok, so we're going to use data. We're going to use all args constructor and no args constructor, and that'll create constructors. It'll create fields. It'll create getters and setters and all that stuff. And now we can create something to. What's wrong?
Add document.
Oh yeah, and add document.
We're mongoing.
Right. Thank you. We need to make this a Mongo. Type, a Spring Data Mongo type, so we have to annotate it to be able to work with the ORM. So there's this. And now we have a basic type. Now I want to save this into the database. So I'm going to create a movie repository to manage the interaction with the database. But I'm going to use a reactive movie repository, not your regular repository. So here's a reactive Mongo repository. And it has all the same features as you would expect from other repositories in Spring Data. It has insert and save and find all and flush and so on. And sorting and paging and all that stuff. All that is here, just as you'd expect, except that notice the interfaces return, or the methods return publishers, subtypes of the publisher. This is a mono, that's a flux. These values are, like I said, they're from the Reactor project. You can treat them like publishers, but they have semantic meaning, right? You can even create custom finder methods. You can say, find all the movies by, what is it, title, right? There we are, string title. All right. So there's our custom repository. Now, what we want to do is write some data to the database, right? So sample movie initializer. And this is going to implement the application runner callback interface, which we should do in both here and later. And implement that. And this is just going to be a regular Spring Bean. And what's going to happen is we're going to inject our repository here, like so. Alt-Enter. Very good. So we're going to inject that here. And we're going to write some data to the database. We're going to say that we have some sampled movies. Now, this is where we encourage audience participation. What we want are some movie names, some sample data based on movies. And we're going to create some movies with the theme of reactive programming, the theme of functional reactive programming. So we have a number of options here. We can say flux.just. I'm going to create some movies. And we'll start off with the suggestion from our friend, the co-founder of Spring Boot, Phil Webb. He gave us this one, Silence of the Lambdas, right? That's a Western movie. It's Lambdas. Never mind, it'll come. So we need some other ones. How many of you have seen the movie with the flux capacitor in it, the science fiction action movie? Which one is that? Thank you. Yes, Back to the Future. ¿Alguien que habla español? But is there any? It has to have like flux or mono or reactive programming, functional. ¿Hay alguien que habla español?
Hispanohablantes. There's an Alfonso Cuarón movie, Y tu mamá también, which literally means and your mother also. But if we change mamá to mono, so we get our mono, our publisher, it's Y tu mono también, which has kind of an extra kick to it because mono means monkey in Spanish. So we go from mother to monkey.
There you go.
Okay.
What? It's fine. It'll come. What about anime? Who watches anime? There's an anime with the word flux in the title. What? Yep. And there we go. Good. So now we've got a few movies, right? That's not so bad. So let's assign this all to a publisher here, and we're going to name this here titles. We're going to now visit each one of these. We're going to say I want to map them into a new movie. So we'll say new movie, and the first one will be null. The ID will be null, but the title will be title. And then we're going to map that into a record that gets saved. So a movie, we're going to save it into the database. We're going to use this.movie repository.save, passing in movie. Now, of course, this could be a method reference, so we'll do that. And this gives us all back. If you look at all that, that gives us a publisher of movies. And then what I want to do is I want to now use all that data, right? I want to use that data that we've just created. And actually, I can clean this up a little bit. I can just delete that. There we are. And this becomes a publisher of movies that have been saved in the database. Very good. Now, what I want to do is I want to delete everything in the database first. Because each time we run this program, it'll add data to the database, and we'll have so much duplicate data, right? So I want to delete everything first. Now, this won't happen all the time. Remember, this is MongoDB. So it won't keep your data most of the time. It'll just lose it,
But once in a while.
Once in a while.
Yeah.
Right? So we have to make sure we delete everything first. We'll say this.movie repository.delete all. Then we're going to say that we want to run this data here. Then I want to say this.movie repository.find all, right? Then what I want to do is I want to actually what happens here? If I just left it there, what would happen? Nothing, right? The Reactive API here, the API that we're using, and by the way, this is a publisher, so you could use that as well. The Reactive API doesn't activate until you have a terminal condition, a final invocation that activates the processing pipeline. We're creating a pipeline very similar to the Streams API in Java 8. So I'm going to subscribe here, right? And when I subscribe, what I'm going to do is I'm going to say I want to just print out the results that come back, like so. So there we are. There's the resulting code. And now we can run the code. And so what is it? Command R? Control R. Okay. So now we run the application. It's running.
Oh, there we go.
Cool. All right. So there we go. There's our 4 records in the database. That seems to be working.
Nice.
Nice. Okay. So what's next, buddy?
Well, so far we've established a fully reactive, non-blocking way of interacting with our data store.
Yep.
And saving the data most of the time. So now we should probably, most of the time. I mean, it counts, right?
Yeah.
It's good. It's better than a stick in the eye.
Right.
So at this point, we probably should start defining our internal API that we'll build upon for the rest of our application. So I'm going to define our service API here. We'll call this class movie service. And I'm going to inject our movie repository, and then let's define our API. So what will we need for a kind of a minimum viable API? Well, we would probably want to return a flux of movies. So we'll get back all of our movies, and we'll just call this get all movies, right? We would also want to be able to return a particular movie, so a mono of type movie, right? So we'll just do this get movie by ID, passing our ID that we're concerned about.
Capital I.
Oh.
Capital I, yep.
Oh boy. All right. Good catch. Picky, but good catch. Okay. Now, at this point, we would also want to, actually, you know what? We need some operational visibility on this, right? Because right now we're just streaming movies. We don't know what we're doing. We don't know what we're getting. We don't know who's watching what. So we probably should have something along the lines of a movie event so we can track the movie events as they happen. So what kind of things would we want to track? Well, we want to capture the particular movie ID that we're interested in watching or checking in on. We would also want to know when that streaming started, so date viewed, for instance. Because what this allows us to do is see what's happening with our movies. If we have a movie that's only being streamed once a year, we probably don't care to keep that movie in our collection. But if we have a movie that's being streamed several times a second, new starts to streaming, we probably want to get other movies that are similar to that. That's where a movie event comes in, so we can track this kind of thing. Once again, we're going to be using Lombok. We're going to have Lombok provide us an ORGS constructor and an all-ORGS constructor, and that should be sufficient, I think. So now, if we go back here and define some of our API, let's see. Oh, I didn't finish off with this, actually. We want to return a flux of movie events so that we can see what's happening as the streaming takes place. So we'll call this method getEvents. Again, we're concerned or interested in a particular movie ID. So let's build our internal API. For get all movies, we would just do a return of all movies, right? For getting a particular movie by its ID, we would return this.movierepository.find by ID, again, passing the ID. And this is where it gets a bit trickier, because if we had millions of subscribers, this would be easy. Chances are we would just query what's happening from our in-memory data grid. We would see that this particular movie is being streamed, and oh, there's another one, and there's another one. But we don't have millions of subscribers at this point, sadly. We don't even really have any subscribers at this point, actually.
No subscribers.
None. Zero. So if you want to subscribe, please see us afterward, and you can be the first. Wow, no takers. Okay, well, see us afterward if you're interested. So at this point, I mean, we typically would do something like this, maybe repository.something, right? We don't have that. So we're going to just kind of generate some events so we can see what's happening, or make it look like something's happening. So I'm going to do a flux.generate and create a sync so that we can create a stream of movie events. So new movie event. Yep. And let's see, we'll pass in our movie ID. We'll give it a current time date stamp. And this is great because this produces just a ton of movie events all at once. Just as many as this little laptop can generate. But that's not really great for a demo because we can't really keep up with that well. So I'm going to just delay the elements a bit and provide it a gate, if you will, just a blip. So one new event per second will be generated and yielded. At this point, of course, we need to indicate that, yes, we're actually producing movie events, and that should get us up and running. Now, that's our internal API, which is great. We can leverage that throughout the rest of our application. But now it's time that we need to produce an external API, because this is where the real power of Reactive Streams comes in. We have different consumers that are wanting to consume this, different clients. So this is our backing service. This is our publishing application. Let's provide the ability for it to provide that, shall we? So I'm going to create a REST controller. Let me ask first, who here is a Spring MVC developer? Okay, so if you're coming from a Spring MVC world, this will look very familiar to you. This is something that I think we've done right within Pivotal, which is not to completely abandon the model that you're used to. We're providing several different ways that you can enter enter into this new landscape and provide a fully reactive stack all the way through. If you're coming from a Spring MVC world, this will look very familiar to you. So we're creating a REST controller, and now I'm going to define a mapping, and we're going to start off with movies, and we'll call this our movie controller, and I'm going to inject our movie service so that we can leverage our internal API, which we took so long to build. You know, this is important, we should leverage this, right? So now I'm going to provide a get mapping for returning, let's see, public flux of type movie. We'll just call this all, this method all, to return all movies across the boundaries. So let's provide a get mapping here for a particular ID, a movie with a particular ID. So we're going to, again, return a mono of type movie. We'll call this by ID. We're going to extract a path variable, our string ID, so we can provide the particular movie we're interested in. And then once again, we're going to do a get mapping for /ID, /events. Oh, hey, lights.
Much better.
And we're going to return a flux of type movie event for this method. We'll call it events. And then once again, we'll use a path variable to grab our ID. And let's go ahead and build this out. So for our all method, we're going to return this .movieService.getAllMovies. Very simple, pretty much a pass-through. For this, we're going to return this .movieService.getById, get movies by ID, passing the ID. And at this point, we've kind of done the heavy lifting for this method, right? So we're going to return this .movieService.getEvents, passing our ID. And that's close. But the default that a REST controller will return is application JSON. And in this case, we're providing a stream of movie events that's going to go on 1 per second indefinitely. So how do we signal? We need some way to signal that we need to keep that connection open to provide that stream of ongoing stream of values. So we can simply specify that we're going to produce a stream media type dot, boom, there we go. Text event stream value. And this signals to our controller that we're going to be producing server sent events. Now, Project Reactor supports WebSocket, it supports server sent events, but since this is a stream, a one-way push of events, 1 per second, server sent events seems like a very logical choice. So let's go ahead and restart this.
It's possible Spring Security, it is possible that Spring Security will have this locked down. We should check.
Good point.
Might have to.
Let's find out.
Yeah, let's find out.
Let's find out. Okay, so clear, boom, boom. Okay, so let's hit that endpoint.
No.
Oh,
Can I ask a question?
sure.
Qui d'entre vous aimait que la lumière était éteinte? Moi aussi. Ok, laissez-le éteint. Merci beaucoup. Hein?
Oh, yes, we are unauthorized. Okay, so let's open our POM, security. Let's go ahead and comment that, and we'll restart. Okay, so now we should be able to hit that endpoint, and we are. We're getting there. So now we're starting to evolve this API. So let's grab the silence of the lambdas. We'll grab the ID for that and see if we can return our mono of type movie. So yes, we did. That's great. Let's see if we can grab our events now. And yes, it all works. And that's great, right? But we can fix it. We can fix that. So what if you're not coming from a Spring MVC perspective? What if you're coming from a more functional reactive background? Do we have time for this?
Yeah.
Can I launch it? Okay.
It's the most important part.
Okay, good. Well, I just wanted to make sure before I just, casually strolled into this. So this is all working, but we can fix it. So I'm just going to comment that out, and we're going to provide a different way of getting in there and doing this. So the first thing I'm going to do is, let's see, how about this? So I'm going to create a bean, and we're going to create a functional routing. So let's see.
Router function?
Yeah. Router.
R?
Yeah. Router. This is the problem when you switch between Kotlin and Java. So router function.
Question mark.
Server.
Question mark.
Request. Response. I usually do it this way.
You sure?
Yeah.
Okay.
It works. Trust me. Okay, so I'm going to create a router function. So now let's see. Return router functions dot route. Okay, so let's define some routes functionally. So I'm going to start off with a request predicates dot get, right? And we're going to start with our movies endpoint, as you might expect. So now what we can do is create a new handler function, right? And that's okay, but that really is kind of jarring, right? Because if you go to handler function and take a look at what that is, that's a functional interface with a single abstract method. So we're jumping back prior to Java 8, which feels a little jarring, right? All we really care about is a way to implement this. So the one way to do this, one way that I typically prefer to do this, is to create a component. We'll call this class movie handler. And let's once again leverage our internal API, private final, movie service, and we'll inject that, and then we're going to create some methods that we can use as handler functions here. So we know that we want to provide a mapping for all of our movies. We also know that we'll want to grab a particular movie by its ID, and we also know that we want to grab our events. So we're getting a server request. Let's return a server response.ok, and let's create the body. So we're going to, once again, use our movie service, our internal API, and get all movies, returning objects of type movie, right? It's pretty clean, pretty easy. Here for our ID, for our by ID, we're going to want to return a particular movie, so server response.ok.body. Once again, leveraging our movie service, get movie by ID. Now we're going to grab our server request and extract the path variable from that. And then once again, we're going to return objects of type movie. And we're almost there. For our events, we're going to do a return server response.ok.body, and we're going to take our movie service, get events, once again passing our server request, extracting the path variable, and grabbing that, we're going to return objects of type movie event in this case. And we're almost there here, but once again, we have to somehow signal that we're returning a different kind of content, not just the basic application JSON. So we're going to specify a content type here of media type dot text event stream, and that gets us there. So let's go up here, and let's get rid of this monstrosity, right? We don't need this handler function now. So let's see. Boom. Boom. Okay, and once again, we're going to inject our movie handler. We'll call it handler. And here we'll take our request, server request, and we will pass that to our handler function all. Yep. And then we can do an AND route, so we can add another route to it. So request predicates.get. Now we need to create our endpoint for a particular movie. And then once again, passing a server request to our handler by ID. And then once again, we'll create our final route, which is request predicates.get for movies /ID/events, so we can grab our events. And we're going to take the server request, pass it to our handler.events. And that's not horrible, right? I mean, that gets the job done, but we can do a little bit better than that because we have a single parameter lambda, and that's easily replaced with a method reference, which cleans that up quite nicely, right? So we can do that here as well. And that's looking better. We can also do some static imports for a couple things here, and that will clean that up nicely as well. And now we're starting to get somewhere. Very concise, very clean. So let's go ahead and restart this and make sure I haven't broken anything, right? That's always bad. I mean, that never happens, but it would be bad if it happened. So, okay, so let's make sure that everything is happening as it should. http://8080 movies. And we're
Perfect.
up and running. So let's grab a particular movie. Y tu mano también. Yeps. Okay, so we're good there. So, whoops. Yeah. Boom. Okay, so now if we go here and let's grab our events and let's see what happens here. And there you have it. So it works. So if you're coming from a more functional reactive background, this is a different way of approaching this that still gives you all the same capabilities, all the same power, but in a style that you're more accustomed to. If you're coming from Spring MVC, that we've got you covered there as well. So back to you. And
Now, is this code ready for production?
No, I mean, we're getting there, right? Step by step.
Step by step. This is very close to being production worthy, but there's a number of concerns that we need to care about before we can deploy this into a production environment. one of these things, one of these concerns is observability. And this observability, it refers to this idea that there are things that I'm going to need to understand about the state of the system, about the state of the application, when something goes wrong. In order to support that, I have here Spring Boot Starter Actuator. Now the actuator exposes endpoints that I can use to surface information about the application, right? Things that I need to know about the application. So in order to use that, I need to actually enable certain endpoints. So I'm going to say health endpoints enabled equals true. I'll say, for example, I want the metrics to be true. I'll say I want the audit events. No, I want the beans dot enabled equals true. So I've now just re-enabled a few things. We'll restart the application with other, leaving those as they are. There's a number of different endpoints there, but for our purposes, it suffices to leave them selected as we have. Now, what we're going to do is we're going to make an HTTP call to 8080/application/health, right? And this endpoint produces information about the application, the health, the MongoDB database, the disk space, all of this stuff that tells me whether the application itself is alive. I also have metrics, for example, METRICK or CS, right? And this gives me metrics that I can then interrogate, for example, the CPU. So I get detailed information about the state of the application. Now, this isn't specifically reactive. The reason I show this to you is to underscore the fact that in Spring Boot 2.0, the metrics, the actuator endpoints, which have always been in Spring Boot, now work in regular Spring MVC. They work in Spring WebFlux, which is this project that we have been using to build our web endpoints, and they work in JAX-RS. So these endpoints are no longer coupled to one particular framework. Now, it is worth underscoring that even though this code that you saw down here is actually, it looks like Spring MVC, this is not Spring MVC. This is a separate project called Spring WebFlux. And as we've been writing this code, you'll see here on the console that it's been using Netty. Right? Not Jetty, not Tomcat, but Netty here, right? It's a fully reactive web runtime that we ship out of the box. You can run Spring WebFlux on top of a Servlet 3.1 container. This is one of the few things that, this is one of the few technologies that's fully reactive that works on top of existing sort of legacy environment middleware. But we, by default, ship this reactive Netty-based runtime that we built brand new for Spring WebFlux. And because this is all being built on top of a fully reactive runtime, you saw Mark earlier being able to take advantage, for example, of a scheduler. This scheduler lets us write declarative code, one line at a time, and have it perform asynchronously. We can write declarative code that will give us predictable results, but it could run on multiple threads. We don't have to worry about that. That's all done thanks to the scheduler. At any given time, we can change the scheduler that's in use. So down here, up here, when I initialize some data in our initializer, where did we put that? Here we go. Here, when we created some data, we created the data on a publisher, and we could have said down here, we could have said that we want to subscribe to that data. We could say titles.subscribe. Sorry, not this one. Where did we go? Flat map. We could have said subscribe on. There we go. We could say subscribe on and provide a custom scheduler, an Elastic one from an executor service, from an executor, from an Elastic scheduler, whatever. We can control the thread pool, but by default, it's got a thread pool. It's doing all that for us. If you were to print out the current thread here, it very well may be different than the thread here, but we don't have to worry about that. The benefit is the result is that it's going to do the most efficient thing that it can by default. Now, we've looked at actuator, and we looked at all this. The last thing, of course, that remains is security, right? So in our build, we have commented out Spring Security 5. Now, they changed the dependencies, so we're going to try. I think this will work, but we'll see. Okay. Now, we're going to use Spring Security 5, which is also at the moment not GA. It's not general availability. So we're going to say security configuration, and we'll say @enable. There it is. WebFlux security @configuration. So what we're going to do is we're going to handle two different concerns. The first concern is authentication. It is answering the question, who is making the request? Is it Mark? Is it Josh? Is it, who? And then the second thing that we're going to answer is authorization. What permission or authority or roles does the person who's authenticated have in the context of our system. So to answer the first question, we're going to take the easy way out. We're going to register some users in a custom user details repository implementation. Right, like so. Or not. User details manager. Guess not. So I am now. Where did they put it? Reactive security?
Sounds right.
Let's just go back one version until we can figure out that dependency. They changed this very recently, so it'll be fine. So we're going to go here, and it's going to be Spring Boot Starter Security Reactive, is it?
Reactive security, I thought. Maybe it is security reactive now.
Well, huh?
It's trying to.
Yeah, I'm waiting for it. Let's go see what GitHub says. All right.
Now you're just slowing down Maven.
Yeah, Maven. Is that it? Did it work? No, it's not it. T. Come on. Oh, the Wi-Fi. Ça bouge pas, ça roule pas. Ça charge pas. It's Java. Well, it was nice while we had it. Okay, here we go. Here's the service. We could try and build a client after this. Pom.xml. Or not.
Officially.
Yeah. Whew. Okay. Security. Spring Security Web. We'll just do the hard way. Okay, so bring in these here. And there we go. So now we're bringing the reactive WebFlex security support, and we're going to create a user details repository, authentication, return new map user details repository. We're going to create some hard-coded users here. So users dot with username, and it'll be JLong, and the password will be PW because of course it's PW. Roles will be just user, and then we'll just build. So like so, then we'll create another user here, user with username MK Heckler, okay? And dot PW dot roles, and of course he'll be admin and a user. Somebody's got to know what to do, and we'll build that. That'll be our details. And we want to handle authorization, right? We want to say that only certain people can access certain endpoints. So here, I'm going to create a security web filter chain. So authorization, and we're going to inject the HTTP security builder and use that to build up the security chain. So we'll say HTTP dot authorizeexchange dot inexchange dot has role equals admin. Then we'll say dot and HTTP basic and build. All right. So done, and done. So let's go ahead and restart. Now go ahead and try these requests against the same endpoints as we did last time. Curl HTTP, or curl minus v, HTTP localhost 8080/movies. Let's see what that gives us. You can see that it says 401 unauthorized. Now if we go back here, we say minus u JLong PW. Still 403 forbidden, right? Now we try one more time. This time with somebody's got the permission, so MK Heckler, and there we go. We get the data coming back from the end. So if I JSON PP, there we go. So we've locked down the service. We've done so in a secure way. So by default, Spring Security uses a thread local to manage the propagation of the authenticated context. That doesn't work in the reactive world. So Spring Security 5 adapts it to work in a reactive world. We have adaptive parallel hierarchy of types that works in the reactive world as they did in the synchronous blocking non-reactive world. All right, so if we had more time,
Yep.
if we had more time, we could look at how to build a client using the web client. But I'm afraid
The bad news is we have a limited time here. The good news is the repo that we pointed out earlier, all that code is in there. So we have a fully reactive, secured web client that you can take a look at that. I was hoping to build that, but time being what it is. And we're happy to answer any questions afterward. We're here today, tomorrow, and please just join us.
So we looked today ever so briefly at Spring 5, we looked at Spring Boot 2.0, we looked at Spring Data K, we looked at Spring Security 5.0, and we looked at, we have just started to look at some of the stuff in the ecosystem. This is just the beginning. Soon we will have Spring Cloud Finchley, which will build on top of Spring Boot 2.0. There's new projects that are built on the Reactive support. One of them is called Spring Cloud Gateway, which is a replacement for something like Zool. It's an API gateway that's easy to use, very, very portable, very fast, fully reactive. It works with different protocols. It supports the Reactive Streams initiative, and it provides out-of-the-box support for things like rate limiting and load balancing and metering. Right. So a lot of different things there. There's more beyond this discussion, of course, but I'm afraid we're out of time. So I want to say, on behalf of my friend Mark and myself, nous vous remercions d'être venus. Merci beaucoup. Et si vous avez des questions, n'hésitez pas à nous les poser en dehors. Ouais. Sorry?
Integrations.
I didn't hear that, I'm sorry. Oh, JWT? Yes. OpenID Connect and JWT, that's in Spring Security 5.0. And if you want to have an identity provider, there's a lot of great identity providers that support OIDC and JWT, including Keycloak from Red Hat, including Spring Security OAuth's authorization server, including, of course, Okta, which is a universal directory. So a lot of good choices there, and they all work very nicely with the client support in Spring Security. Other questions? I can't see, so you have to speak up. Okay.
Thank you.
Merci beaucoup.